So welcome everyone to the information session with Checkerspot. This is AIChE's Winter GBM #1, and we are so excited that you're here to join us to learn about this awesome company and AIChE in general. So we're going to start with a quick land acknowledgement, if my slides will go. My computer's been having some troubles today. There we go. So the UC San Diego community holds great respect for the land and the original people of the area where our campus is located. The university is built on the unceded territory of the Kumeyaay Nation. Today, the Kumeyaay people continue to maintain their political sovereignty and cultural traditions as vital members of the San Diego community. We acknowledge their tremendous contributions to our region and thank them for their stewardship. Okay. So we wanted to talk for a little bit about AIChE. So AIChE stands for the American Institute of Chemical Engineers. If you are new to the the organization, that's what we stand for. It's a long name, so that's hence the acronym. The goal of AIChE at UC San Diego is to promote the professional development of chemical engineers through various events such as information sessions and workshops. We also have programs such as AIChE Projects, which allows you to work with a team on various environmentally relevant issues, which is pretty cool. We have AIChE Family, which is our mentorship program, which pairs older students with younger students and helps them figure out helps the younger students kind of figure out their place in the university, helps them do better in their classes, provide some friendships and things like that. And then we also have AIChE Committee, which helps people do some extra stuff on the side of their education, get some extracurricular experience, put stuff on your resume and all that fun stuff. We also help chemical engineers connect with other majors, professors, fields, and industries. So for example, tonight we're going to be talking to Checkerspot, which is a fantastic company. Other times we have faculty mixers where you're able to talk with professors and you're able to mix with other students and learn about their research and other classes that are being taught and things like that. So the goal of AIChE is really to create a community of chemical engineers and other majors and just promote professional development as well as just a community among everyone, because we all need that, especially during Zoom times when it's hard to connect with people. So yeah, if there's any events that you would like AIChE to put on, feel free to contact anyone on board. You can go to our website. I believe it's aiche.ucsd.edu, something like that, and click on any one of our names to find our emails. So yeah, if that's anything you're interested in, feel free to find us and talk to us. Other than that, that is about all I have to say about Checkerspot. Or about AIChE, sorry. It's been a long day. So Checkerspot, just as a quick introduction, they are a biotech company that focuses on developing high-performance materials while being eco-friendly. They were founded in 2016, and they are based in Berkeley, California. And as a fun fact, they were named after an endangered butterfly, the Edith Checkerspot, to symbolize their commitment to the environment. This is the company that is wonderfully going to talk to us tonight. I'm very excited. So please welcome Checkerspot.
Hey guys, thanks for the invitation. I'm going to share my screen right now. It's good to be talking to people in San Diego. I spent a lot of time at Scripps Research Institute and lived for about 8 years down in San Diego. I'm going to talk today about Checkerspot, give you an overview of our technology, spend a little bit of time talking about what we call our molecular foundry, what we can do with it, the types of materials we can make from it. I'm going to spend quite a bit of time talking about our business model and animating a technology through a brand. It's very important to what we do. And then a fair amount of time about talking about some of the materials we've developed and some of the things we're moving on to going forward. So just a quick overview of the company and what I'm going to talk about today. So Checkerspot, we're a technology company at our core. We're also a certified B Corp since our founding. A B Corporation is a company that, rather than what's a traditional S Corp, which is in essence bound by law in some instances to serve its shareholders, a B Corporation has different commitments and different goals. And for us, key to those are environmental stewardship, sustainability. So that means when we make business decisions, we can place those things at the top of the list rather than the balance sheet or investors. And that's just part of how we build the company. Our technology is comprised of 4 pillars. I'll talk about each of those. First is the molecular foundry. That's the host organism and how we make, in essence, raw materials, and how we process those raw materials, grow our microalgae, extract our oils, how we do molecular biology, molecular genetics in that part of the platform. The second pillar of our technology is based on polymer chemistry and material science. How do we modify, in some cases, those raw materials and then employ polymer chemistry to turn them into other entities, things like thermosets or thermoplastics or textile finishes? And then how do we apply material science to evaluate the physical properties of those materials for end use applications? The third pillar and a key part is really fabrication and applications development. Once we've developed a material, how do we take it and turn it into something useful that ideally an end use consumer will want to buy and purchase, and that hopefully is better for the environment? And the fourth pillar is consumer engagement. So it's great to be a technology company. It's really a lot of fun from an R&D perspective to be developing new and novel materials. But Charles Dimler, my co-founder, and I, when we got together and decided to form Checkerspot back in 2016, key to the entire process and our business plan was that we would animate this technology through a brand and connect directly to consumers. So in our previous lives, we had spent, decades basically in industrial biotechnology, making typically molecules, small molecules, or things like biofuels, and trying to sell those to large corporate partners. What we learned during that time is that is somewhat of a fool's errand, because the challenge as a small startup and industrial biotechnology company is you have two things that those larger companies want. There's two things those larger companies want that you don't have. One of those is scale. You're typically starting out very small. You don't have enormous scale. And what follows from that they want is price. So you don't have something that's available at a commodity price because, of course, you've just developed it. So the thing that a brand solves for you is it allows you to animate that technology, take those molecules, utilize, in our case, polymer chemistry and material science, and then fabricate them into something useful that's tangible and real, and that people can hold in their hands, and they can see what your technology can bring them, rather than talking about some interesting triglyceride oil we might develop and how they might use it. We skip all those steps and we go do that. And then we show that to people. And ideally, we create value through the brand and also at the same time connect to consumers. And the premise was that in doing that, other companies would see what we had developed, how we developed it, what the applications were, and therefore want some of that stuff, want that thing. And that's really the problem you're trying to solve as a startup. How do I create demand for what I have? If the only thing I have is a triglyceride oil and I'm trying constantly to sell it to DuPont or Dow or a Cargill, I don't have price, I don't have scale. They have stuff they're already using and you're competing in that world. But when you have consumers that pay for what it is you're making, now you've created a market and you have demand, and other people want a piece of that. And so what we've seen over the last 5 years that we've been doing this in Checkerspot is that premise is sound, it works, and we've developed novel materials, and now we've created external demand outside of our own brand from other brands who now want that material. And that's really the problem you're trying to solve as a startup, is how do you generate revenue? How do you generate sales? And so that's really a key part of what we do. So this culture that we have is really data-driven. We learn a lot by doing. It's back to that applications development. It's really, really important to us that we do a lot of that work to understand how do you work with these materials. I've already talked about animating technology through brand. I'll talk about that all the time. It's my favorite thing to talk about. It's super important. And as a consequence of what we do and how we do it, we go from a microalgal cell all the way, and we'll talk a lot today about backcountry skiing, to a finished ski. So that's a very heavily vertically integrated company. We go from concept all the way to finished good, and we have to make that raw material all the way through. So a triglyceride oil, chemically convert it into something, create a polymer, take that polymer, fabricate it into an end-use product that's multi-material, and then sell that to an end-use consumer. So that's a lot of work. We're actually quite small. We're fewer than 70 people, and we try and be really efficient, which is of necessity. So biomaterials are attracting a lot of investment and attention these days. So these are just a series of sort of milestones that we've achieved over the years. Again, we founded in 2016. We did our first financing in 2018. So there were a number of years. Nina Reyes, who's on the call and helped organize this talk, was one of the very first team members at Checkerspot, along with two other members who, you know, we didn't draw salaries. We went without money for about 18 months and just kept chipping away. But we really built a company at the end of the day. So I think that's something to take away from this talk. You know, if you really have a passion for innovation and for changing the world, I think it's something that, you know, if you really want to do it, you'll figure out a way to do it. We delivered our first product in 2018. That was in collaboration with a partner we still have today, Beyond Surface Technologies, based in Switzerland. They make non-petroleum based textile finishes. And we also have a research and development program that we're working very closely with them on today. In 2019, we closed what was called our first Series A financing for $13 million. And in 2019, in pretty short order, we finally were able to put together enough resources to launch that brand that was so important to animating this technology, and that's Wonder Alpine. So Wonder Alpine is an outdoor brand. The first products that we've used to animate the technology are backcountry skis. But I think, as you'll see in the months ahead, we're moving into other finished goods. And key among those in the hard goods space will be snowboards and split boards this year. But we'll also be moving into soft goods in short order. We achieved that B Corp certification in 2019. That's something we're very proud of. Wonder Alpine is also a certified B Corp brand. That's also very important to us. And then in July of 2020, we launched really our second, our third commercial material, our second material in Wonder Alpine, which was a cast polyurethane material. And then in August of 2020, we had another round of financing of about $40 million. In December of 2020, we signed a really important joint development agreement with a very important brand in the outdoor space. And then most recently in November, we signed a joint development agreement with a partner, AIChE, in the personal care space. And so all of these things emanate from this technology platform that we have. And there we go. So, you know, how do we do this, and what are these three pillars? We've already talked about them to a certain extent, but we call this platform the Wing platform. And again, it's comprised of these three pillars: a molecular foundry, the microalgae that we engineer in many cases to change the types of triglyceride oils that they make. We'll talk quite a bit about that. We then take those triglyceride oils and we apply polymer chemistry and material science to create some new material. And then we fabricate those materials into some type of prototype and ideally end-use consumer product. And then a really key part of that is the consumer engagement, connecting with the consumers. And these consumers are important because, you know, they're going to care as much about how we do what we do as, you know, what it is we do per se. So they're very engaged in our B Corp status, our focus on sustainability, and a movement away from petroleum. And many times that dictates, not many times, all the time, it dictates who those consumers are that we're marketing to and how we market to them, because they're really engaged in terms of how we're going about this and how we're doing it. So I'm now going to shift gears a bit and talk about that molecular foundry and what it is we do there. So we work with microalgae that make these triglyceride oils. So triglyceride oils are comprised of a glycerol backbone and fatty acids. And if you look out across what's called the oleochemicals industry today, for all the triglyceride oils that are out there, and there's roughly about 30 commercially available triglyceride oils. Those oils are only made of about 14 individual fatty acids, the moieties that are attached to that glycerol backbone. And it's those fatty acids and how they're arrayed and their ultimate composition that determines the physical properties of those triglyceride oils. And in many cases, what their utility is. What can I do with those? So with just these 14 fatty acids and a small number of actually commercialized seed oils today, there's a multi-billion-dollar oleochemicals industry that has grown up around this. And most of these materials can in one way or another replace petroleum incumbents. So if you go out in nature, however, what you find is that there's a huge diversity of fatty acids out in nature. And so this sort of scatter plot that I'm showing you here, these orange dots represent those currently available fatty acids that are found in seed oils that are grown at commercial scale and commodity prices. But if you start to assay oil seeds that are found in nature, and these are oil seeds that are never going to be commercialized, they're never going to be grown at agricultural scale at commodity price, what you find is there's an incredible diversity of fatty acids out there that have a variety of different functional groups, degrees of saturation, presence or absence of double bonds. And what we can do at Checkerspot is we can tap into that diversity. And what that allows us to do is to create entirely new molecular entities, feedstocks in essence, for new materials. And so that's really the purpose of this molecular foundry. And so to sort of dive into that a little bit more, in this microalgal host that we work with, what is it that we're able to control and tune and modify? And it's all the things that are really important to the physical properties of a triglyceride oil and the physical properties of a polymer, for example, that we might develop from that. So chain length is just what it sounds like. How long are those fatty acid moieties? So anything from 8 carbons long to 26 carbons long, we can access through this microalgal platform. Saturation, which basically is the presence of double bonds. Double bonds are really important because they not only dramatically alter the physical properties of a triglyceride oil, but they're really useful handles for doing chemistry, for doing polymer chemistry on. They provide something we can grab onto with catalysts and reagents and modify the oil and turn it into something that has another application other than the oil itself. Some of the things that we impart onto those saturated or unsaturated double bonds are functional groups. And it turns out that triglyceride oils, we can also introduce those in vivo. So that can allow us to skip a chemistry step that we might do on a triglyceride oil, but instead perform that in the cell. And that has incredible implications for reductions in cost, for example. The other thing that we can control is basically position. So microorganisms and oil seeds, higher plants that make triglyceride oils have a really exquisite machinery for controlling all these facets of fatty acid biosynthesis. But in addition, they can control which fatty acid goes where on that glycerol backbone. And that has huge implications for the physical properties and performance of an oil. So a really good example of this is cocoa butter, key ingredient in chocolate. And the thing that everyone recognizes about chocolate and M&Ms, M&Ms, they melt in your mouth, not in your hand. The reason for that is the physical properties of cocoa butter. Cocoa butter is what's called a structuring fat, and it has a very high level of the fatty acid stearate, oleate, stearate in that precise order. So stearate is at the first position, oleate is at the second, and stearate is the third. And that triglyceride, that tag species, constitutes about 70% of the tag species in cocoa butter. And what that does for cocoa butter as a fat is it gives it a very sharp melt profile. It melts right almost precisely at body temperature. So at 35 degrees, it's rock solid. So at room temperature, it's solid, but at 37 degrees, it melts, and it melts really quickly and very sharply. And the sole reason for that is where those fatty acids go. And if I change that register, if I make stearate, oleate, I develop something that behaves more like a wax. It's rock solid at about 50 degrees. So that is very, very important. And we can tune that, and we can control that. And the last thing is occupancy. How many of those fatty acids go on that glycerol backbone? Do we want 1, 2, or 3? And those materials have interesting end use applications as well. So how do we do this stuff? The key is actually those oil seeds out in nature. So we're able to do this because these microalgae that we work with, they're in essence the evolutionary progenitors of these higher plants that make all these oils we use today in the oleochemicals industry. So the oil biosynthetic machinery, the fatty acid biosynthetic machinery in our microalgae actually gave rise to this machinery in higher plants. Because of that, at a molecular genetic level, at an enzymatic level, the two systems are very compatible. So what we do in a nutshell is we will go to oil seeds in nature, and we will extract the RNA from those seeds. And basically what we're doing is we're interrogating the population, the entire population of expressed genes in that seed that give rise to the oil it makes. And by taking a bioinformatics approach, we can sort through all those transcripts that we analyze, in essence, cDNAs, complementary DNAs, and then pick out the ones that, through our knowledge of bioinformatics, we can pick out the ones that might introduce a double bond at a particular position, or might allow us to elaborate a fatty acid that's 8 carbons long instead of 18 carbons long. And so it's a very facile system, and we've become very good at that. But that, in essence, is what we do. And that's how we access this diversity in nature. And all that happens through this microalgal platform. So a little bit more about microalgae. And I'll talk a bit more about this. So it may come as a surprise to you. You think algae, you think sunlight. That's not how we grow our microalgae. We actually grow them in fermenters, and we feed them sugar. And I'll talk in a subsequent slide about why that is. But this photomicrograph on the left is basically an image of microalgae coming out of one of our fermentations. And they look pretty simple here. They're a single cell. They're about 10 microns in size. And what happens when they produce oil is they just fill up with these oil droplets. And if you look at this figure here on the right, this is showing just a time course of how that develops in a fermenter. And so this is simply the biology of the organism. This is nothing that we've engineered them to do. This is simply what they do. And so if you take these organisms and you feed them a nitrogen source and sugar, they will simply divide. They will make copies of themselves. And we call that their vegetative phase. If you then shut off that nitrogen supply, and typically we do this at about 26 to 28 hours in our process, if you shut off that nitrogen and continue to feed them sugar, they will take all that sugar, just like you would, and they will incorporate it into fat, into triglyceride oil. So they will stop dividing, And all the increase in biomass that we see in a fermentation is due to the accumulation of this oil within the cell. And it's trapped within the cell. It is entrained within the cell. So in that respect, they're very, very much like an oil seed. And what these micrographs here are showing you, we've stained the cells with a stain called Bodippy, and it fluoresces when you hit it with a certain wavelength of light. And so what you're seeing here is this increased accumulation of oil in the cell over the time course of the fermentation. So this process in total is about 96 to 120 hours to make cells that are filled up with oil. So a little bit more about the process. So a lot of people think algae, microalgae, you must use sunlight. Why do you use sugar? And it turns out there's a lot of microalgae that will actually metabolize sugar and turn it into lipid. This aerial shot is a facility that I spent about 3 years at in the late 90s. That was right before I came to the Scripps Research Institute in La Jolla. But it's called Cyanotech in Kona, Hawaii. And it's a 90-acre facility. It grows microalgae. It's all grown phototrophically. So it's on the Kona coast of Hawaii. It is probably one of the world's best places to grow microalgae. It is a coastal desert, which means it's in Hawaii, gets very little rainfall, about 8 inches of rain a year, incredibly sunny, just a perfect place to grow microalgae. And that facility, if it were producing triglyceride oil, would be capable of making about 758 metric tons of oil in a year. About, we produced biomass in that facility. We could produce about 325 metric tons of biomass per year on 90 acres. So if I contrast that with a microalgal host that I can grow heterotrophically, and this image is from a plant down in Brazil that when I was previously at a company called Solazyme, we built with our partner Bunge Oils in a joint development agreement. That is a facility that occupies about 12 acres, and it utilizes sugar derived from sugarcane. There's a sugarcane mill right out the back door of this plant, and literally they take a small skip loader and shovel sugar out of piles and scoop it into big hoppers that go and are formulated into sugar syrup to feed the fermenters in the plant. That plant in a year can produce somewhere between 70 and 100,000 metric tons of oil. And that's simply because the productivity in a heterotrophic system is so much higher than in a phototrophic system. So if you look at the cell densities that we can get in a phototrophic system in a gram per liter basis, you're doing really good if you can get to about 0.5 gram per liter dry cell weight. And it will take you anywhere from 7 to 14 days to get to that kind of culture density, which means there's a lot of water in that material that you need to get rid of. When we grow material heterotrophically in a single high density fermentation process, we'll get to about 250 grams per liter dry cell weight. So this is orders of magnitude higher. So it's just a much more robust process for generating biomass or a product if it happens to be triglyceride oil. And the key limitation for phototrophic growth is sunlight, because as these cultures get denser, they start to shade themselves. And sunlight, as it is the energy source, whereas sugar is the energy source here in heterotrophic growth. And that sunlight, when it becomes light limited, everything slows down. Metabolism slows down, oil accumulation slows down, and growth slows down. So that's why heterotrophic growth of the right microalgal species is really just superior, and why we use those organisms. A second reason why we do this relative to, say, working in a traditional oilseed crop is time. We work in a microbial system. And so in a microbial system, our doubling times are about 4 hours. In an oilseed crop, that doubling time is measured in months. So the time it takes me to introduce a new trait in an oilseed crop, I mean, the fastest you're going to get there is probably on the order of about 8 years. But in microalgal systems, we've literally done that in as short a period of time to go from initial development to running large scale. And these are in this case, we're 500 cubic meter fermenters in as little as 5 months. So there's just a completely different time scale when you're engineering these types of organisms. So now I'm going to shift gears a little bit and I'm going to talk more about the materials we make, why we make them. And this slide says a lot about sort of our ethos. Performance versus sustainability is a false choice. So one of the challenges you face as a company that's moving into sustainability and bio-based ingredients is people saying, yeah, but green materials don't work as well. They don't perform as well. And so that goes back to the premise that Charlie and I had when we started the company, that we needed to animate this technology through a brand. It wouldn't be enough to talk about the sustainability benefits of the material. We needed to show it to people. They needed to be able to hold it in their hands. And ideally, in the case of Wonder Alpine, they needed to be able to use it, recreate with it, and experience it. So that, again, it's back to that idea of animating a technology through a brand and applications development. Really, really key to what we do. So a super quick tutorial on a ski and what do skis look like and how are they built. And this was one of the key reasons when we started to think about the company and what was the material we were going to make? What was the brand that we would use to animate the technology? What space would we occupy? What market would we go after? So when we recruited Matt Sturbins, who's the general manager of Wonder Alpine, and we got to know Matt, we got to know a heck of a lot about skis. I really, became engaged in the opportunity here. So this is a typical ski layup. And the first thing you notice if you're kind of interested in developing new materials, there's a lot of materials in a ski. And to me and to us at Checkerspot, that represents opportunity. There are so many different places here where we have opportunities to introduce bio-based materials. It's a relatively complex layup. There's many opportunities to use bio-based materials and to improve the overall sustainability of the ski and improve the manufacturing processes that we use to build a ski. But basically at its core, there's a top sheet. There's a couple of sheets of fiberglass on the top layer, another sheet of fiberglass on the bottom. There's a bottom sheet material, which is typically ultra high molecular weight polyethylene. The only thing we probably can't develop around are the steel edges. We've got small pieces of rubber that present opportunities for development that provide damping. It has a wood core, and our first introduction was of a material, a foam, an algal foam that served to lighten these cores. And that was very important to backcountry skiing because you want something that's lightweight so you can ascend. And the second material that we introduced was this sidewall. The sidewall material is really there to prevent moisture penetration into the rest of the ski, and particularly the wood core. And that wood core is what provides the flexibility and the rebound to the ski without compromising too much on the weight aspect of it. So the ski was really, really kind of a playground in which we could seek to introduce a variety of different bio-based materials while at the same time addressing performance properties and issues that we wanted to solve. So it was just a really, really unique opportunity. So this was an example of the cast urethane materials that we developed, where we were comparing this against an incumbent material, ABS. It's used all over the ski industry. It's a plastic that's widely used in a variety of industries, if you've ever seen like black drain pipes, black sewer pipes, whatever, that's typically made of ABS. It's a plastic that's everywhere. This material that we developed is 60% bio content. Again, the bio content is derived from a triglyceride oil that we chemically modify and then formulate to create this thermoset plastic, this cast urethane material. But the really interesting thing is when you look at the physical properties, and here we're looking at some of the flexural properties of the material this is a 3-point bend test, a tensile test. We actually have greater tensile strength than the ABS material. And that was something we also found that we can tune based upon the rate of cure of the material. So here's just, a really prime example of we can arrive at a material that has superior physical properties to something that's widely used in the plastics industry today. This slide is a bit busy, but this was an example of some foam formulation. Remember, one of the materials we introduced into our ski layup is a high density algal foam. This is our standard foam. And this was some development work that we were doing to see if we could upcycle waste materials into our original foam formulation. And we had a good deal of success actually in taking one of our waste components from our ski processing and reincorporating that material into our standard foam formulation. And we actually improved the compressive strength, which is a key specification, a key physical property of that foam. We actually found we could improve that by incorporating a waste stream. So that's another example of if we were simply developing a molecule and trying to push that out into the universe, we'd never have the opportunity to do this kind of applications development. And so that's an example where we found an entirely new use for a waste material with our material. And that's something that we're seeking to further develop within the brand initially. So I'm going to show you a quick video right now that's going to encapsulate some of those things I talked about, but it's a really nice visual to allow you to appreciate and see how we do what we do. So I'll roll this now. If I can.
In our world, small changes have massive impacts. That's why we're always searching for new materials to innovate with. So we wondered, what if we could create better materials for skis from natural building blocks? That's where the science of microalgae comes in. For the first time, we're using biotechnology to design new materials from microalgae for backcountry skiing. We start by growing microalgae in fermentation tanks to produce entirely new types of oils. Novel oils that petroleum can't produce. Oils that are the molecular building blocks for new advanced bio-based materials. Materials like algal polyurethane and algal cast PU that we use in our lab in Salt Lake City. Our mantra is, algae in, petroleum out. First, we created the algal core, a backcountry ski core using microalgae-based, high-density polyurethane laminated against domestically sourced aspen. This delivers superior dampening and optimal strength-to-weight ratio. Then we developed our algal wall, a liquid cast polyurethane derived from a proprietary algal polyol that natively bonds with the core without the need for adhesives. The result is a stronger bond, superior strength over edge, and better flex and absorption compared to common materials. And we're applying this construction and biomanufacturing to the Vital 100 and the Intention 110. For the first time, we're designing materials specifically for skiing, improving performance and eliminating about 2 pounds of waste per ski. Heightening the backcountry experience with new bio-based materials that outperform all others. Made by nature, designed for the backcountry.
Okay, so I think you can see from that example, I think that gives you kind of a good overview of the process and how we utilize those two materials in our ski. And that's, I think that's just a really nice graphic. Um, so with that approach, by animating this technology through a brand, we've just gotten a huge amount. So this is that fourth part of the Wing platform, that consumer engagement piece. We've just generated a huge amount of interest and buzz in the ski community in general. And I can't tell you the number of times. So I spend a lot of time in Salt Lake City, although I'm primarily based here in Alameda. But the number of times that folks in the design lab in Salt Lake, where Wonder Alpine is located, will tell me that when they're skiing in the backcountry, where there aren't a whole lot of people, someone will recognize the Wonder brand or the Wonder skis. Or if they don't, they'll say, "Where did you get those skis?" So again, that ability to connect directly to the consumer is just so important to this idea of brand. And it, in our opinion, it's really integral to really growing and developing, you know, a bioindustrial company, because the other approaches just really haven't worked for us. So the net effect is that the brand has had a huge impact, not just on the brand, but on these materials. So today we find ourselves in a position where other brands, winter sports brands, have come to Checkerspot and are now using our raw materials in their ski builds and their layups and doing a lot of prototyping as well, which was the entire premise for the idea of animating that technology through a brand. So that feels really great to us. So that's it. That's kind of, that's all I got. So if you have questions, happy to entertain those.
Yes, questions would be awesome. If anyone has any questions, feel free to unmute or to drop them in the chat, and I will read them for you. I did have a question. I was wondering about um, the sorry, oh my gosh, my words. Um, how many components of the ski do you think could potentially be made by your materials? Are you doing everything right now, or do you think there could be more in the future?
No, you can't do everything right now because everything takes development. So the ski cores, definitely. The sidewalls, we continue to innovate on formulation for sidewalls to improve things like impact resistance. There's another component that I didn't talk about that's called a tail block. That's a great opportunity for innovation for us. There's another component which I didn't show in that layup called a boot plate where the bindings mount into. That's an opportunity for innovation, actually something we're actively working on. The bottom sheet is potentially an area for innovation within the ski. One thing that we think about, though, it's not just about, you know, cramming all of our materials in that ski. It's about sustainability. So it's also recognizing there's a lot of other options out there, more sustainable options. And so one of the things that Wonder wants to be known as is developing and sort of giving voice to a lot of other technologies that can have a positive impact.
Awesome, thank you so much. And Rebecca, I see you have your hand raised.
Yeah, I had a question. Well, first of all, do you ski?
I don't. I am not.
No.
No.
Wow. My next question was, how do you decide what type of polymer to develop next? Because there's clearly like many different types of polymers and many of those can probably be made through your process. So how do you decide which one comes next in the steps?
So a lot of that is driven by the brand and trying to solve a problem. So I can, you know, I'll tell you, and it's no secret, when we developed our sidewall in our first year application, which was a lot of development work, there was so much concern around aesthetic. It's a component of the ski. And for us at Checkerspot and Wonder, it was the first time algal materials would be broadly visible to the consumer. They'd be able to touch it, feel it, they see it. So the aesthetic was super important. And much of the development work was focused on that. As we launched it in 2020, and we continued to formulate, we realized we could make much higher impact resistant material. While we didn't have issues, we recognized that impact resistance would be key on EDGE. So that became a driving force for further innovation and formulation development in the cast urethane space. So a lot of the driver comes from us internally and the problem we're trying to solve. Secondarily, though, as other winter sports adjacencies have come to us to use our materials, we now have the opportunity to work with them and solve their unique problems, some of which are entirely different and many of which are related to the way they manufacture their ski. Everybody makes skis differently. The layups all look similar, but the way they do it, everyone's different. And so what we get to solve is how do we use our material in their manufacturing process? So the value in that is we learn so much more about these materials we make and how to tweak them to get them to do what they need to do. And we own all that. And what happens when you own all that is now you just have this vast repository of knowledge, which is an ability now to solve still more problems for other people. And so that's what we envisioned this brand would do through animating the technology. But it's really driven, much of the driver comes from wonder internally.
That's an awesome answer. Thank you so much. If anyone else has any questions, feel free to drop them in chat. I see that, oh, we have Jeremiah. So how do you determine if the physical properties of your polymer materials meet consumer demand?
Do a lot of testing. And sometimes there's what we call coupon testing, which is kind of reductionist, literally just the material itself. Sometimes we make more elaborate coupons where we actually lay them up into skis. But most importantly, we prototype into skis. And while I don't ski, I think 95% of the employees at Wonder ski. So there's a group of brand ambassadors, and Matt Sturbins, the general manager, is an avid backcountry skier and X Games. So these people go out and they break stuff, and that's how you learn about them. So we can create a new formulation, a new layup, and be on the snow in about 3 days.
That is so fast. Oh my gosh. It's
And
impressive.
that's why we've co-located. I didn't mention this, but our material, a key part of our material science and polymer chemistry team is co-located right in the same shop as the brand. So we can formulate, prototype, and get on the snow very, very quickly.
That's awesome. We have another question. Did you all ever try the products yourself? Also, I might have missed this, but are skis your main focus?
So yeah, as I just mentioned, everybody at Wonder and a lot of the folks at Checkerspot. So to be clear, Wonder is a brand. It's owned by Checkerspot, but it is a brand. So yeah, lots of folks use the skis. We prototype the skis as part of the development cycle. So right now, snowboards and split boards are being prototyped for the 2022 launch, as well as next year's ski models with some additional tweaks to sidewall formulations, and some other things are being prototyped today. So yeah, it's just a lot of testing.
Awesome. We have a whole bunch of questions in the chat, so let's see here. Would you guys develop a snowboard? It's kind of like a ski, or maybe for a snowmobile, but then the snowmobile would waste gas. I don't know. What's your thoughts on that?
Well, I mean, probably again, it's all back to kind of the look and the feel and the brand. So Wonder Alpine is an outdoor brand. We just happen to have started in skis because it's a great way to animate the technology. But as you watch Wonder over the years, the brand and its reach will continue to grow. So again, as we move into soft goods, as we move into snowboards and split boards, think of an REI or a North Face or a Patagonia. That's kind of the potential, but with a very different core in that the ability to take technology and animate it. That'll be a key differentiator.
Awesome. Rebecca, did you have a question too?
I did. So in the video, it mentioned that the walls of that cast polyurethane actually bond to the wood. I was so interested in how that happens.
Oh, that's by the very nature of polyurethanes. So the two principal components in a polyurethane are a polyol, which is basically a molecule with hydroxyl groups on it, more than one. You got two, you got a polyol. So you combine a polyol with an isocyanate. So that chemistry between those two bonds creates a urethane linkage. It turns out wood, if you think of cellulose, there's free hydroxyls hanging off of crystalline cellulose. It's a great thing for isocyanates to bond to. And so polyurethanes in wood create a natural adhesive. When we use ABS in a ski layup, we have to glue it. With urethanes, they inherently bond, which is just an added benefit. It eliminates a step in the layup, so it's great.
That is way cool. And Rebecca, I had similar questions. It's
Yeah.
just so interesting to think about this adhesive that doesn't need an adhesive. It's
I
incredible.
know.
Let's see, we have some more questions. What does an everyday workday look like at Checkerspot?
Depends on what you're doing, which is typically everything. Yeah, we wear a lot of hats. The product specialists in Salt Lake City for realistically, 10 months of the year are churning out skis and snowboards and split boards. The folks here in Alameda are more on the development side, primarily focused on the molecular foundry. The material scientists and polymer chemistry team in Salt Lake are focused on formulations and solving problems for and with Wonder, as well as other winter sport adjacencies. So a lot of prototyping and testing. There's a lot of engineers in Salt Lake that are really good problem solvers. And then we also have now an outpost in Minnesota for process chemistry. And that group is very, very focused on one of the key chemical modifications that we do to our triglyceride oil and driving down the costs of that process at large scale. So it just depends on who you are and where you are and as to what you're doing.
I just wanted to add to that. Yeah, one of the greatest parts about working at Checkerspot is our diverse team. Some people are on the snow, as Scott has alluded, testing, and some people are in the lab. Some people are doing materials testing. So we have such a diverse subset and experience of teams. So every day looks kind of different for every person.
Yeah, so Nina is a prime example. So Nina, started out when we were all wandering in the wilderness 5 years ago and living in hideous shared workspace areas, watching rats eat construction workers' lunches.
Literally.
When we finally got lab space, Nina, and for the last 4 years, has split her time between communications and fermentation development. So there's a prime example of somebody who spends a lot of time in the lab, but at the same time is doing a lot of the outward facing stuff.
I think it's pretty incredible that you all wear so many hats. That's not something we get with most of the companies that we have come talk to us are really big, so everyone does like one job, but this is so different. It's really refreshing.
Yeah.
We did have another question. If there are internship opportunities, what would interns be doing to help the company grow?
It really depends on where they are. So, we just had interviews today for interns that would be working with the lab ops people, operationally to keep the lab running, but also looking where there's additional time to help out in fermentation development, for example, or downstream processing or screening. So it really depends. Or we might bring in interns that are really part of a single group. So they might be in Salt Lake City working with the materials science group, or they might be here working just with the firm development group. It just depends.
Where can we go to apply for those internships?
Nina can tell you all about that.
You can reach out to me and Allie directly. We put our emails in LinkedIn on the chats.
Awesome. Everyone who's been looking for an internship, this is your opportunity. Matisse, I see your hand is raised.
Yeah, okay, this is a bit of a tangential question, but with sustainability being at the forefront of your company, are the sugarcane plantations in Brazil considered sustainable as well? Is that eating away at the Amazon or something and we just don't know about it?
Yeah. So that's one of the key components of why when we were back at a previous company, we elected to build a plant in Brazil, was the sustainability aspects of sugarcane. So key to that is, first of all, co-location with the fermentation facility with the sugarcane mill. So you're not trucking and moving syrup or sugar long distances to a plant. It's right out the back door. But more importantly is the way a sugar mill runs, particularly in Brazil. So sugarcane, you harvest the cane, you bring it in, you crush it actually several times to extract the syrup. And you basically condense and boil down that syrup until you get to sugar, or you use the syrup directly to make ethanol or something, or rum, something like that. But that cane, after you've pressed it, that gets dried and turned into something called bagasse. So it's basically all the cellulose that's left over. In sugarcane mills, they burn that bagasse. It's cogen, and it provides all the energy to run not only that sugarcane mill, but also that fermentation facility, and generate sufficient excess power to send back to the grid. The additional benefit of particularly the mill down in Brazil, they do ethanol fermentations there as well using that same sugar. So when you do an ethanol fermentation, you obviously distill off the ethanol. You've got stuff left over afterward. That's called vinasse. That material actually goes into a distribution system. It's called fertigation, and that gets applied back to the cane fields. The bagasse, after you burn it, that ash, that goes back to the sugar cane fields as well. And the fermentation facility, it's using a significant amount of water and steam. All that steam, that condensate, all of that condensate is recaptured, and that goes back to the sugar cane mill. So you have a really integrated sort of refinery system and agricultural system that are sort of not a perfect closed loop, but pretty darn good. So for that reason, when you use sugarcane in this process, it's really, really efficient and highly sustainable. In terms of rainforest, no matter where you put a plant, you're going to use land. You don't grow sugarcane in the same latitudes and geographies where there is rainforest, though. You grow them in a region that's called Cerrado. It's more sort of plain-like. If you think of like the savanna in Africa, it's really analogous to that.
Is this by like the Pantanal?
Well, it's not. Pantanal is typically wetter, but the Cerrado is more dry. So it's kind of a drier region, and it's a heavily agricultural region. They not only grow sugarcane there, there's rubber tree, citrus, just a lot of agriculture.
Okay, thank you. That sounds amazing. The whole process.
Yeah, and that I would say that contrasts with North America if you were using corn dextrose, and that's a real challenge. In North America, we've really dislocated corn production from a corn wet mill where you would make corn syrup. So typically those corn wet mills might be on a river, and you would barge in corn, and you're not doing a lot of cogen. Oftentimes those facilities run off coal. And there's really not an opportunity because of the way that system grew up in the United States, mainly to get to scale really fast. We dislocated that production system from the field. And if you could get back to that in some way, you'd be more like Brazil, but it would require a disaggregation, right? So maybe you'd have more corn wet mills dislocated all across the country. And, big companies don't like that. Although, I don't know, in today's climate, there's a lot to be said for not having all your eggs in one basket and having stuff decentralized. But that's a key difference between sugarcane and corn dextrose as a feedstock.
Thank you.
That was super interesting. I learned a lot. Wow. I had a question actually. What are there chemical engineers who work at your company, and if so, what kind of things do they do?
So the chemical engineers would typically be folks that we find in firm development, for the most part. And so that's, typically when we recruit somebody into firm, they often have a chemie background, although also on the material science side. So they may have originally been a chemie, but then they've gotten into materials. And now, they're kind of almost exclusively working with materials.
Very, very cool. Rebecca.
Hi, it's me again. I had another question. You mentioned having these functional groups introduced in vivo, and I was wondering how that works. Is that the process of taking the seeds and putting that DNA into the microalgae?
That's right. Yes.
Okay.
Do that in vivo. It's finding an oil seed that hydroxylates and introducing that gene or genes. Usually it's a combination of genes to now introduce that hydroxylation onto the oil in our seed, in our microalgae.
Right. Do you think that there could possibly be a way to take more synthetic polymer materials and be able to create using the algae and making it different in such a way that you are able to create oils that are not currently produced by regular plants?
We actually already do that. And the reason why is, when we look at an oil seed in nature, it makes a particular type of oil. And our access, which is really a function of the types of fatty acids it makes, because we can combine these genes combinatorially, we can make an entirely new oil. So an oil that's got very short chain lengths, but now hydroxylated fatty acids on it. That doesn't exist in nature, but we can make that and have made something like that in our system. So
That's
it's
incredible.
the combinatorial nature of what you can do with molecular genetics.
Thank you.
If anyone else has any questions, feel free to unmute or drop it in chat. I guess I had one question while we're waiting for anyone else who has any final questions is, what do you enjoy the most about working at Checkerspot?
Oh, I just think it's the diversity of stuff and just the challenge of, when we started the company, my co-founder, Charlie Dimmler, Charlie was the one who was very focused on materials. And I was a little bit skeptical. Because we knew the host, we knew what we were going to be making, triglyceride oils. And there hasn't been a huge amount done in the material space, particularly around commercializing things in the way we wanted to with these types of materials. But once we started to really do the work and imagine what we could do and animate what we can do, which actually happened relatively early, then it was the challenge of figuring out, well, how many different ways can you tweak this stuff to solve a particular problem? I think that's what I enjoy the most. And also I guess the other big part is a key part is how do you pull this off and build a successful company? Because otherwise it's just a research project.
Sounds like a pretty incredible research project. So I'm glad it worked out into a company. That's amazing. Let's see, I don't see any more questions in chat, so I'm going to go ahead and share my screen again. Let's see here. This might take a second to load. All right, can you all see the question and answer session? Excellent. All right, so we already covered the Q&A and we got a lot of fascinating questions. I'm really glad with all that discussion. That was really wonderful. we had a quick favor for all the students in the audience. We have a technical workshop coming up, and we just wanted to get your interest in what you would like it to be. So if you have a second, please go to this tiny URL or scan this QR code and just tell us what you'd be interested in doing a technical workshop on. And I believe that's my last slide. Yes, so that is my last slide. I'll just leave this one up. So yeah, thank you everyone for coming. As we mentioned, please do this workshop, sorry, poll, oh my goodness. But yeah, other than that, thank you for coming. I hope you have a wonderful night. Thank you to Checkerspot for coming. We really appreciate your time and your energy and the wonderful slideshow and just learning all about this fantastic technology and this company. So yeah, thank you everyone for coming, and I hope you have a wonderful night.
Thanks a lot, guys.
Thank you for having us. That was amazing. And the conversation and questions, one of the most engaged groups we've had. So this was awesome. Thank you, Eleanor and Diana, for organizing.
Of course, we are super happy that you guys were able to come. This is a real treat for us.
Awesome. And yes, please reach out to me or Allie for any further questions.
Yes, and I can send out the contact information in an email afterwards. So everyone will have your information if you'd like it.
Yeah, please. And also follow Checkerspot LinkedIn, Instagram, and all that for more updates.
Awesome.
Thank you. Have a great
Thank you, everyone. Have a good night.
Thanks, guys.
Thank you so much.